Hi, welcome to the session 4 of Module 2, Data Science for Engineers by the Department of AA and DS. So in this lecture, we will see a classical algorithm in the field of data science called the nearest neighbor classifier. This is the first non-trivial algorithm that we will be seeing in this course. So in the coming modules, you will be uh, seeing more advanced uh, both supervised and unsupervised learning algorithms. And let us see what we are trying to achieve from the nearest neighbor classifier. So this is a simple non-parametric Bayesian learning algorithm used for both classification and regression. So what is classification? If the target variable, the variable that we are trying to predict, if it contains multiple classes, then uh, given a new data, we will try to classify it to the correct category. So you can have two categories, then it's a binary classification problem. Or if you have more than two categories to predict, then it becomes a multi-class classification problem. And in regression, we are trying to estimate the value of a continuous variable. Like if you have a historical data set that talks about the where the target variable is, let's say, the salary of a person. So the feature salary is a continuous variable, right? So if you are trying to predict when a new data point comes, that is when the information about a new person comes, if you are trying to predict that person's salary, it comes under the class of problems called regression. So we can use k-nearest neighbor both for classification and regression. And the key idea in this algorithm is to classify a data point based on the majority class of its k-nearest neighbors from the given feature space. And as you can obviously see, this algorithm is a supervised learning algorithm. It's a supervised machine learning algorithm. So why it is supervised? Because we are given with the target variable. The historical data has the target variable, and using this target variable and the historical data, we devise the nearest neighbor classifier. And some of the use cases for nearest neighbor classifier is in handwriting recognition. It's used in recommendation systems. It's used in medical diagnosis, etc. So as you can see here, our aim is to assign label of nearest training data point to each test data point. Right? If you are doing like that, it becomes a first or one nearest neighbor. So generally we call this nearest neighbor classifier as kth nearest neighbor classifier, KNN. Okay, let us see how it works by going with an example, and after going through the example, we will also describe a detailed algorithm for nearest neighbor classifier. So k nearest neighbor. Okay, so as you can see here, we have got two axes. We have data in two-dimensional space. The x-axis is termed as x1 and the y-axis is x2. And you have two different classes here. And class 1 is represented by green data, and class 2 is represented by using red color. Green color and red colors are used. And assume that you are getting two new points whose categories are not mentioned. So as you can see, two plus symbols using black color, right? So there are two new test points. So our aim is to use KNN to find out the correct category to which each of the two new data points must belong to. Okay, it can belong to either green or red class, right? Let's see how we can find this out by using KNN or kth nearest neighbor algorithm. So 1NN, that is where k is 1. Okay, so what happens here is we will find out the nearest point to the new point and whatever is the label of that nearest point, we will give the same label to the new data. So here one of the plus or one of the new data is near to a red labeled data, so we can, if you are using one NN, we will just label that as red, and for the other one it is green, the nearest point is green, so we can label as that new point is green as it belongs to green category. So this is 1NN, that is we are using the first nearest neighbor. Now what happens when we go for a higher value for k? In KNN, if you are going for a value higher than k equal to 1, so let's say we go for k is equal to 3, then what it does, it finds out the 3 nearest neighbor to the new points, and as you can see for the first point you have 2 green points and 1 red point. Those are the nearest points, and what we will do, we will take the majority vote, that is out of this 3 different data, what is the majority category to which this data belong to, and clearly here it is 2 green and 1 red, they are the 3 nearest neighbor, and 2 is the majority here, I mean green is the majority here with 2 different uh, with 2 different values, so we can conclude that it belongs to green class because 2 of the different data belong to green but only 1 belongs to red. And now if you go for the second new data, here also the story is the same. Out of the 3 nearest data point, 2 of the data belongs to green color and only 1 point belongs to red color. So we can conclude for the second part also that this second data also belongs to green color. So this is when we are using 3NN, 3 nearest neighbor. And like that we can, let's say we can go for 5 nearest neighbor. We can find out the nearest 5 neighbors, and as you can see here for the first point, when you find out the 5 nearest neighbors, 3 of them belongs to green color, so we will conclude that this one also belongs to green color because 3 is the majority, right? And same thing goes for the second point also. Okay, so this is using the concept of k nearest neighbor. So this is the whole algorithm of k nearest neighbor. So this is a very classical and the very basic learning algorithm that we will learn in this course. Now there could be a question that might have popped up in your mind, that why we are using only odd numbers for k. So I started with k equal to 1 nearest neighbor, and then k equal to 3, and then k is equal to 5. So why did I skip even values? Why did I skip 2 and 4? So the reason being, if you put 2 or 4, there is a possibility that we will not get any majority. That is, one, if you are talking about 2 nearest neighbor, maybe one of the data belongs to red class and the other belongs to green class. So there should be some mechanism to break this tie, right? So that's why we are always going for odd numbers. So if it is odd number, we will not be able to divide it equally 50-50. At least one of them will be a majority data in that point. That's the reason why we always go for odd numbers. And as a thumb rule, you can take the value of k, right? In the k nearest neighbor, you can take the value of k to be square root of n, where n is the total number of data points in the training data. Data points means the total rows in the data table. Okay. So let us conclude this session by defining the pseudocode for k nearest neighbor algorithm. So we only saw the case in which we are solving this for a classification problem. So in the previous example, it was class 0 and class 1. So what if it is a different kind of problem, like a regression problem? So let's see how we can solve that by using KNN. So this is a pseudocode. In step 1, we choose the number of neighbors, that is the value of k. As I said, we will select one of the odd numbers. Now you have to calculate the distance between the new point, the new, that is a query point, and all the other points in the training data. And you could use a distance measure like Euclidean. Euclidean measure is usually used in Canon. And then you select the closest k neighbors to the new query point, which are the closest, that is the k points whose distance is the minimum from the query point. And then you just, in the last step, you just vote or find the average. Voting means we are trying to find out what is the majority color. So if you are going for classification, we go for majority voting, right? So like we saw in the last example, we see that to which category or which color, like in the last example, so to which category does the majority vote falls into. So whichever is that category, we will assume that the new data point also belongs there. Okay, so that is how classification works. And how regression works. So if you are talking about a target variable that is a numerical or a continuous variable, then how can we predict, how can we regress the new data point, the target value for the new data point. So in this case, what we will do, we already have the k closest neighbors. Now what we will do, we will find out the average value of the target variable for those k closest neighbors. We'll just find out their average value for the target variable, and whatever average value we get, we fix that value to the new query point. So this is how k nearest neighbor algorithm works for a regression problem. And just again, please note that the Euclidean distance is used as the distance measure in this algorithm. Okay, thank you.